Hi Year 11, sorry I am not there with you today, but you will have virtual me. And we're going to do a little bit of work on reaction of metals and writing equations for those. So if you could take your blue book and take a title of reaction of metals at the top. In the corner, if you put a little topic reference, this is unit 2.1. Just so when you're looking back that it's nice and organised. And then if you take a little subheading, the first type of reaction that we're going to look at and write equations for today is the reaction of metals with oxygen. So title of reaction of metals, subtitle of reaction of metals with oxygen. And then a little reference in the corner, unit 2.1 to our topic. And what we're going to be doing this period is having a look at how we write balance symbol equations for these reactions. So if you now take out your periodic table, we're going to have a wee look at what we need from our periodic table in order to write our balance symbol equations. So the first thing we want to do is highlight our diatomic elements, because when they appear in an equation we have to write them as the symbol and then a little 2 after them. So for example, hydrogen is one, so rather than writing H when hydrogen appears, we have to write it as H2. Okay, so hydrogen is one of them, so if you could highlight that or colour that in somehow, make sure you can still see it. And then we have nitrogen, oxygen, fluorine, and then all the way down group 7 as well. Okay, so highlight those or colour those, and then do a little key for yourself up at the top somewhere, maybe up here, that your highlighted elements are diatomic. Okay, so when they appear on their own in an equation, you have to write them as their symbol with a little 2 afterwards. Okay, the other thing we need from our periodic table are our valencies for our swap and drop. Okay, if you remember group 1, they all have a valency of 1. Group 2 have a valency of 2. Group 3, a valency of 3. Group 4, a valency of 4. And then we start to count backwards. So group 5 has a valency of 3. Group 6 a valency of 2, and group 7 a valency of 1. So if you could write that at the top of each group. So that means that anything in group 1 has a valency of 1, anything in group 2 has a valency of 2, anything in group 3 valency of 3, and so on. So you look to the top of your group and you find your valency there. So we'll need that for writing our equations, so please fill that in on the periodic table you've been given. So what we're going to work on today is writing a balance symbol equation for each of our metals for their reaction with oxygen. So we're just going to do it in order that we burnt the metals last Friday and the order that they are in your book. So that means our first metal is aluminium. So first of all, you always need to write your word equation. So when aluminium reacts with oxygen, we form aluminium oxide. Okay, it's really important to write your word equation first so you know where to work from. So then we are going to convert that into symbols. Okay, so what I want you to do is leave about 4 lines or so underneath that for our working out, and we're going to convert each of these terms into a formula. So let's start with aluminium first. With these metals, it's simply going to be the symbol of that metal. None of these metals are diatomic, so for aluminium, I just look to the periodic table. I see that its symbol is Al. Remember to leave your 4 lines in between. Then we've got oxygen, but if I look at the periodic table, I can see that I've highlighted that. Why have I highlighted it? Because it's diatomic. When the element is on its own, it is diatomic, so I write it as O2. Then comes my arrow, then I've got aluminium oxide. That's a compound, so I'm going to have to use my swap and drop for that. So first thing I write down is my element symbol. So I've got aluminium first of all, which is Al. Oxide is just oxygen that has become a negative ion. So I write down the symbol for oxygen, which is O. Now notice I'm not writing O2 now, and that's because when it's part of a compound it is no longer diatomic. So it would not be right to write a 2 afterwards. Okay, next thing I need to work out is my valency. So if I look to aluminium and look at it on the periodic table, you'll see it's in group 3, so it has a valency of 3. Oxygen, find it, it's in group 6, but look up at the top, group 6 have a valency of 2. At this point you ask yourself, can I cancel this down at all? And you ask yourself, is there a number that I can divide both of those by to make it a simpler ratio? But there's not. If you were to divide by 2, you would get aluminium with a valency of 1.5, which you can't have. So this is as simple as it gets. So we swap and drop, and we get the formula of Al2, the 2 has swapped over from the oxygen, O3. And we write those numbers down at the bottom and without circles. Okay, so I'm ready to put that into my equation, Al2O3. So my equation is written, but it is not balanced. And if you remember, we put boxes in front of our formula to remember that when we are balancing an equation, we can only put numbers in those boxes. Any number we put in those boxes will actually multiply our formula, the number of atoms that we have, by that number. So to help us keep a track of our elements, we will make a list. So we've got aluminium and we've got oxygen. Let's write that on the right hand side as well, because remember what we're trying to achieve is the same number of atoms on the left hand side than on the right hand side. Let's count up our atoms on either side. So we've got aluminium on the left hand side, there's no number after it, so it's just 1 aluminium. And we see we've got O2, which means there's 2 oxygens. On the right hand side, however, we have 2 aluminiums and we have 3 oxygens. So this is actually quite a tricky one to balance, but we will get there step by step. So first of all, I might look at my list and say, well, I need more oxygens on the left. So what number could I put in my box to get more oxygens? Well, we could start by putting a 2 in the box. If I put that 2 in a box, remember that that multiplies the number of oxygens I have. So I now have 2 times 2 oxygens, which is 4. Now you can see that hasn't fixed my problem because I actually still need, I now need more oxygens on the right hand side. So what I'm going to have to do is put a 2 in this box. But again, remember to update your list each time. So now I've put a 2 in the third box. I now have 2 times 2 aluminiums, which is 4. And then I have 2 times by 3 oxygens, which is 6. Remember, it multiplies and not just adds on. Okay, so we're getting closer now. And you can see that I have 6 oxygens on the right. So I now actually need to go back to my list on the left hand side. So now I need to think, what should I change that number in front of the oxygen to make sure I get 6 oxygens in total? Well, if I multiply 3 by 2, I'm going to get 6 oxygens. So I changed that number to a 3, and it's okay to do that, to put a number in initially and then have to change that. Sometimes we have to do that in balancing equations. And lastly then, I just need to balance my aluminium, and that's easy because any number I put in that box will just change to the right number of aluminiums. So I need 4 aluminium, so I simply put 4 in my box. That changes my number of aluminiums to 4, and you can see my equation is balanced. To keep it nice and neat, then underneath, could you write your final equation without the boxes? So we have 4Al plus 3O2 giving you 2Al2O3. And actually this is probably the hardest one that has already been done for you. Okay, so what I want you to do now is work through the rest of your metals and write a balance symbol equation for them. For each of them, write the word equation first and then write your formula, and then balance your equation. So the next one on your list is calcium. So it will be calcium plus oxygen, giving you calcium oxide. Okay, so I want you to leave 4 lines, write your formula, and then balance. And then finally rewrite your final equation underneath without the boxes. Okay, and each of them will need balanced. The ones I want to point out to you are your transition metals. So when you look to the top of their group, they don't actually have a group number, and therefore they don't have a valency. For copper and for zinc and for iron, if you look at the back of the periodic table, and for example for zinc, you'll see that it appears as Zn2+. Now that's the ion, and when you write it on the left hand side it'll still just be Zn. But when you're trying to work out your formula of zinc oxide, you look at the charge and you take the valency to be 2. So when you're writing the formula of zinc oxide, it will be Zn with a valency of 2, oxygen with a valency of 2, and then if you look at that, this is an example where you can cancel down your valencies. You can divide both of those by 2 and end up with Zn1, O1, swap and drop, and you just get ZNO, remembering that we just leave 1s out of our formulas, so ZNO. Give these a go. It'll be good practice of writing equations, which we did last year. Give them a good go. Try and get through the 8 metals and their equations with the reaction with oxygen. Once you finish today's lesson, if you put your booklet and your periodic table into your blue book and just leave them in class, and I will collect them for our next lesson.